to the next point. We should ensure that whatever we see is clear.
That means work is being done, we can see that it is in opposite direction. It is against.
Hi, my student at home. You are welcome to Kaduna State e-learning program in chemistry. Today, we will be looking at chemistry, and the topic is petroleum. You will recall that in our previous lesson on organic chemistry, we made mention that the basis of the study of organic chemistry is hydrocarbon, where we made mention that there are two major sources of hydrocarbon, the petroleum and coal. Today, we are going to look at what petroleum entails. We will be looking at this topic under the following outline: nature of crude oil, refining of crude oil, petroleum product, that is, in other words, fractions, uses of petroleum product, cracking of petroleum product, and we have what we call octane number of rating, and lastly, petrochemical. My student, whenever we are talking about this petroleum as one of the major sources of hydrocarbon, it is a dirty, dark, viscous liquid. Another name for this petroleum is crude oil. It occurs naturally, and it is a dirty, dark, viscous liquid. It is viscous because it shines, and it has an unpleasant smell. And another thing you need to know about this petroleum, it is a complex mixture of different substances. We have the kerosene, the petrol, the petrochemicals, diesel, and so on and so forth. How is this petroleum formed? I know this is one question that you may want to ask. This petroleum is formed over millions of years by the decay and decomposition of plant and animal remains that are buried deep beneath the earth crust under high temperature and pressure in the absence of air. The petroleum or crude oil is trapped down through a hard surface rock under the ground. Whenever we are talking about this, the petroleum is always together with the natural gas, and it is formed as a result of this death and decay of plant and animal remains that are buried deep beneath the earth crust. This petroleum is usually associated with high viscosity, and it is volatile. What we say is volatile, it escapes through the air. Whenever we are talking about this petroleum, the nature of the petroleum, whenever the petroleum is formed, it is piled up beneath the earth crust and under a very hard sedimentary rock. Under a very hard sedimentary rock. During this process, bacteria will now act on it and then convert it into what we call hydrocarbon. Whenever this is converted, the petroleum product or crude oil is gotten either on land or inside the sea. When it's on land, it is called onshore. When it's inside the sea or oceans, we call that one offshore. Whenever this petroleum product is discovered, we have scientists like geophysics, geologists that will carry out geological survey to ascertain the presence of this mineral called crude oil. The engineers will now come in, use their engineering technology to drill the oil from the sea or on land. Don't forget, we said it could either be on land or on sea. That's why we have what we call the onshore and the offshore. Now, whenever we're talking about this petroleum product, petroleum is one of the most important commodity. It was discovered in Nigeria in 1956 in a village in Bayelsa called Alogbiri. This Alogbiri is found in Bayelsa State, and in 1956, later petroleum as a product was also discovered in other areas of the Niger Delta, like Akwa Ibom State, Bayelsa, Rivers. We also have petroleum in Igbo State, like Imo. We also have petroleum in Ondo, but we call those areas the Niger Delta region. In Niger Delta, we have areas like Ogbema, Ogeli, Kokori, and so on and so forth. In the whole world, countries that are blessed with this product are wealthy nations. For instance, we have petroleum in USA. We have petroleum in Saudi Arabia. We have petroleum in Venezuela. We have it in Nigeria, Libya. Most of these countries that I've just mentioned are wealthy nations because of this important commodity. Like in Nigeria, 80% of our economy depend on these wonderful mineral resources, petroleum, which is a product that is mineral product that is derived through this process of petroleum. When you are talking about this petroleum, we have two major types of petroleum. We have heavy petroleum and light petroleum. Like the one we are having in Nigeria is a light petrol. It is light because it has less sulfur content, and that is why at the international market, people are always happy to buy our own petroleum product because it has less sulfur content. The demand is always very high. Whenever this petroleum is drilled from the ground, they are stored in a reservoir, after which they are distributed to various refineries for us to distill them into various fractions. In Nigeria, we have three major refineries. The refineries are, we have the Kaduna refinery, the Port Harcourt refinery, and the Warri refinery. Kaduna refinery is one of the largest refinery, of course, built by the Italian company, and we are happy to have a refinery here. That petroleum crude oil is pumped all the way from the Niger Delta down to these various refineries, where a process of separating these various fractions is going to be carried out. The process we use in separating the various fractions of this petroleum product is called fractional distillation. How is this fractional distillation carried out? If you have been to the refinery, you will have what we call a fractionating tower. You will discover that the fractionator is a source of heat is supplied of about 600 degrees Celsius in a furnace, and then into a particular container. In chemistry, we describe that container as the fractionating tower. You can see the diagram on the board. This is a fractionating tower. The various products having been collected on this fractionating tower are subjected into a source of heat supply. You will recall while you are in your SS1, you were taught that we have various separation techniques. One of it is this fractional distillation, whereby it is used in separating various fractions of petroleum product in which the boiling points are closely related to each other. Don't get confused. Don't get yourself confused with the simple distillation. In simple distillation, the boiling points are widely related, but in fractional distillation, the boiling points are closely related to each other. The substances are completely miscible. At a particular temperature, when you heat, the first product you see that will get out at the temperature of about around 50 degrees Celsius is the refinery gas. This refinery gas, the carbon range is ranging from carbon 1 to 4. And whenever the boiling point is up to 30 degrees Celsius, or all the substances that are refinery gases that are inside, that are contained in the mixture, will escape and be collected through what we call a fractionating trace. The next to that is what we call gasoline. Another name for gasoline is petrol or naphtha. Another name for it again is PMS, premium spirit. Now, the carbon range is ranging from C5 to C10. And the temperature range is from 40 degrees Celsius to 180 degrees Celsius. We have what we call the next, as part of the fractionating product, we have what we call the paraffin. Another name for paraffin is the kerosene. Don't forget, we said the petrol is a complex mixture of different substances. After the paraffin, we have what we call light gas. The light gas is having carbon ranging from C16 to C20 with a temperature of 250 degrees Celsius to 300 degrees Celsius. Down to that, the fifth one, we have what we call heavy gas oil. Another name for this heavy gas oil is lubricating oil, or in other words, we call them lube oil. This lube oil has a carbon range of C20 to C30 at a temperature of 300 degrees Celsius to 350 degrees Celsius. And then we have the last but not the least is the asphalt, known as bitumen. It's not every petroleum that has bitumen in it. Like that of Nigeria, we don't have much of it because ours is a light petroleum. Now, this is ranging from any carbon ranging above 30 degrees to at a temperature of 350 degrees Celsius. This temperature that we are talking about, each time you are heating this mixture, when it is time for them to, when it is exactly that temperature, they will escape and then be collected by the fractionating tower. Now, what are the uses of these various petroleum products? Like the first one we mentioned is the refinery gas. If you are moving towards the refinery, you will see flames of fire. That flame of fire is supposed to have been used as an important fuel, that we can use that for domestic and industrial uses. We use that one we put them inside our gas cylinders so that we use them as a source of heat in our respective homes and industry for heating. Next, we have the gasoline. We know the use of gasoline, petrol. It is used as a fuel for what? For our automobile engines. We have our electrical generators, and it can also be used as a solvent. When we say solvent, something that you can use it to dissolve something. For instance, you can dissolve paint using petrol. Next, we have the paraffin oil. That is the kerosene. This kerosene that we are talking about, you agree with me that we use it in our respective home as fuel in our wig lamps. We use it also as fuel for what? Jet engines. You see jets, they use this kerosene as their own fuel, but in a more purified form than the one we are used to. We also have what we call the diesel, commonly used also as fuel. When we say fuel, something that burns out to give out energy. Then there are buses, there are cars that use this diesel engine. So we use them. We have tankers, ships, all they use them as their own fuel. Lubricating, from the word lubricate, meaning to soften. It is used to soften engine parts. We also have what we call the bitumen. Yeah, that thing that we use in making, tarring our roads and also roofings to protect water from percolating through our roofs. These are the various fractions of petroleum, just to mention but a few. Some of them can be redistilled again. Then we have other products. You will agree with me that more than 1,000 chemicals that we have in making drugs today are byproduct of these petrochemical. We call them petrochemical. Chemicals that are gotten from the redistillation of some of these petroleum products. However, one of the most important products in this as one of the fractions of this petroleum product is the petrol, which we call naphtha. In other words, we call PMS. This petrol that we are talking about is very, very important Today, whenever there is petroleum shortage in our country, our means of transportation will seriously be affected. As such, the petrol that is gotten from the distillation of this, fractional distillation of this petroleum product is not enough to cater for our timely need. As such, there are processes that are carried out in the refinery to increase the quantity of this petroleum product. One of these processes is called cracking of petroleum product. It is carried out by the engineers. What is this cracking? It is simply the breaking down of larger chain hydrocarbons into smaller chains to produce petrol and other smaller substances, smaller compounds. For instance, you can see the example. This cracking usually occurs either in the presence of a catalyst or a heat. Whenever we are using catalyst, we call it catalytic cracking. Whenever we are using heat, we call it thermal cracking. Then, it is not every carbon range that we use. We use carbon range anything above 11 to crack. For instance, you can see the example. We can crack in kerosene. We break kerosene. We don't need kerosene, all that. We can put kerosene in an open container, add a catalyst like manganese dioxide, and then when we heat it, it is going to break and then to give us petrol and then other smaller alkenes. Our major concern is the petrol. Then how do we get back our petrol? We carry out what we call distillation. By the time we carry out distillation, we now have our petrol, which we are going to use. We can use other compounds, other fractions like bitumen and so on and so forth. Now, we have another process that is usually carried out at the refinery industry also. This is to tell you that it's not every petrol that is good. There are petrol that when you put them in the name of you want to use them as fuel, they can cause what we call knocking in chemistry. That knocking is as a result of what we call uneven combustion in an engine. So to curtail that issue of uneven combustion, we have a process also at the refinery industry that is usually carried out, and we call that process reforming. What is reforming? Reforming is the process whereby straight chain alkenes are converted catalytically. When we say catalytically, we add a catalyst into it, into a branching isomers, cycloalkane, and benzene. The purpose of this practice is to improve the quality of the petrol in order to prevent this problem of knocking that we are talking about of our engine. So in order to do that, we reshape the structure. We add up a chemical known as lead tetraethyl as a catalyst that we are talking about, which will now change and reshape it to give us a desirable quality of petrol. Now, in order to know whether this petrol is good or not, there is what we call octane number of rating. What is octane number of rating? Each gasoline or petrol that you see is of grade, and the grade range is from 0 to 100. For instance, each grade gasoline is rated according to the term known as octane number of rating. The octane rating is based on the property of its straight chain. Don't forget, in chemistry, whenever we have a branching, the better it is for us to have a good petrol that will have less effect on our engine. So we add, whenever we have such cases, we mix these two chemicals. We have two chemicals. We have the heptane and another chemical that we call 2,2,4-trimethyl-pentane. This 2,2,4-trimethyl-pentane, when they are mixed in the ratio 1:1, then we have 50 of the octane number of rating. But where the percentage of the 2,2,4-trimethyl-pentane is higher than that of the heptane, then we have up to about 100% carbon, 100% petrol that would be good for us to use. I believe you have learned. My student, one of the most important products that we use in recreating nature and make nature to use better is this petroleum. By this, we are going to end this lesson for now. I would like to invite my noble colleague in person of Mr. Ibrahim Umar to come forward for a brief summary, and also he's going to read out the assignment for you. Thank you. See you another time for another presentation. Stay safe. Stay at home.
Good day, my students. I am Uncle Ibrahim Umar. I'm here to give you a brief summary as well as assignment of the day on the topic petroleum. It was wonderfully presented by Mr. Williams. But the first thing I would like to say is, don't get confused. There is difference between petroleum and petrol. Petrol is the liquid or the gas that we add to our cars and it will make it move, while petroleum is the mixture of all these gases that are contained together, which we separate them by the use of fractional distillation. Now, under the nature of crude oil or petroleum, we said we have two types of petroleum. We have the light petroleum and the heavy petroleum. The light petroleum has less sulfur in it, or no sulfur, just like the one we have in Nigeria, while the heavy petroleum has a large quantity of sulfur in it, which is also an impurity in it. How do we refine petroleum? We refine it by adding the crude oil collected beneath the ground to a fractionating tower in which is heated to certain temperatures. At each given temperature, fractions are given off. Examples of the fractions we have are: 1, refinery oil, which we know it as cooking gas. It has a very low quantity of or value of carbon from carbon 1 to carbon 4, and it is collected at low temperature of less than 30 degrees Celsius. Remember, it is our cooking oil. We use it for cooking in our cylinders. Then the second fraction is the petrol that we use for our generators and our cars. It has a value of carbon from 5 to 10, and then it is used for our cars and for our petroleums. Then we have the kerosene as another fraction. This kerosene is used for our lanterns as well as our stove. We have the light gas oil, which is called the diesel. This diesel is collected within the temperature of 250 degrees Celsius to 300 degrees Celsius, and it is used for our buses, trains, and so on. Heavy vehicles, they use it. And then finally, we have the bitumen and the lubricating oil, which are also very important. Then the next important concept is the cracking and reforming. Now, what is cracking? Now, when you have high percentage of heavy chemicals like the diesels and the kerosene, and we prefer petroleum because it is used more than the other fractions, then what we use is we crack it. That is, we convert it from that high fraction to a low fraction. We use two methods for cracking. It's either thermal cracking or catalytic cracking. When you apply heat, you crack it thermal. Then when you use catalyst, then that is what is called catalytic cracking. Also in reforming, when the petroleum does not burn smoothly, that means it has straight chain hydrocarbons, then what we do is we add chemicals, or we add what we call catalyst in order to reform it, in order to change it from straight chain into a branch chain. And the process of converting it into branch chain is called reforming. Now, reforming is very important because it prevents your engine from knocking. It is very important to know that a thermal cracking, you are converting, or in cracking generally, you are converting a higher fractions of petroleum into a lower fraction that are needed, like in petrol. While in reforming, we are changing it, or we are arranging it to have a better quality of petrol. Having said that, my students, I'll move into our assignment of the day to ascertain if learning has taken place. Assignment. Number 1 in your assignment is 1A, Distinguish between cracking and reforming. 1B. List 4 fractions of petroleum and their uses. 1BII. State the importance of cracking and reforming to the petroleum industry. Question 2. When a compound with carbon-12, hydrogen-26 is heated under suitable condition, it's decomposed into octane and alkene. Now, first question, write the equation to represent the reaction. Second question, name the process in the petroleum industry that is based on this type of reaction. My students, if you solve your assignment or you have any other observation, question, or anything, you can contact Mr. Williams Ishaku on his number 081-606-70920, or you can contact Mr. Philip Mammon on his number 080-2659-8861, or of course you can contact me, Mr. Ibrahim Umar, on 070-3620-2842. Thank you very much, my students. Remain safe, stay at home.